Okay, in this video I covered the pegging classification. I working on the dataset of breast cancer available on the Kaggle. You go and simply download from the Kaggle. Now I want to import some important libraries. Uh, and For adding some visualization, I want to use the matplot and seaborn. Okay. Now I want to load my data. You can load your data using the Scikit-learn datasets, import, and then load breast cancer. Okay. Now after this, uh, I want to import some important things from model selection. Uh, let's say the trend test split for splitting my data into training and testing, and the GridSearchCV. Okay, for the better result. And now one more thing, the cross val score, and I think I can also use the learning curves. Yeah, that's it. Now I want to use the ensemble learning technique, as we all know, and that is our bagging classifier. And also I want to import some more classifiers like bagging regressor and not classifiers, bagging regressor and random forest classifier and random forest regressor. Okay, now I want to import my base model, that is the decision tree. Sorry, decision. Hmm, I think. Okay, sorry. Import decision tree classifier and the decision tree regressor. Okay, and now at last I want to import some metrics, some important metrics for measuring my performance metrics. Import the accuracy score for my accuracy, confusion metrics for a better understanding of my model, and then classification report. And you can also use the mean squared error and the R2 score for regression. I think that's enough. Yeah. Hmm. Okay. Yeah. Now let's run it. Okay, it's working. Now first of all I want to do the classification. Okay, bagging classification. I simply want to load my data in the data, load breast cancer, and I set x equal to data and y is equal to data dot uh, target. Okay, now I want to show you the shape of my x, in which the shape of, you can say shape of data sets x dot shape, sorry, small x, and I also want to print the number of features to show you how many features are there. X dot sorry, not x, okay, x dot shape, and let's say 1. Okay. Okay, it's working, I think. Shape of dataset x dot shape, expand tab. Okay, what is this? Not expand tab there. You just simply have to write data dot data. Okay, now it will work. As you can see, you have a shape of dataset of 569 rows and 30 features, and the number of features is also 30. Now I want to show you one more thing here, and that is the classes, and you simply use the data dot target names. Okay, we have two classes. The first one is the malignant and the benign. So basically these are the dataset as we all seen. uh, we can see in this data, just a minute, I just load this file in the Excel file. Okay, as you seen, we have a M and B. So this one is M and this one is B. Okay, so I'm not using exactly like this dataset. I'm using the dataset of the Scikit-learn dot. Basically, this dataset is from the inbuilt dataset of Scikit-learn. Okay, not this dataset. You can solve this problem on this dataset. It's fine, but I am using this one. Okay, now let's move to the train and test split. The important step. I use the simply the random split. Let's say x train, x test, y train, y test is equal to the train test split. And now you have a x and y, and your test size is 0.2, let's say, and random state, okay, let's say is 0.3, and the random state will be a 42 and 25 to 2y. Okay, it is working. So our data is successfully split it into the 70 and 30 format. 70% for the training and 30% for testing. Now let's move to the base decision tree classifier. Okay, first of all I want to show you how decision tree works with this dataset. Basically how much accuracy the decision tree will give you on this dataset. Then I will use the bagging. Let's say decision tree is equal to decision tree classifier, and the random state, let's say 42. Now let's fit the data into decision tree. Your x train and the, sorry, capital Y train, and now let's predict it using your decision tree dot predict and your x test, and let's say store into the y predict decision tree. Okay, it's very simple. You can see it. And now for accuracy I use the accuracy a variable, let's say, and the accuracy score, and in which use the y test, capital Y, okay, and the y predict DC entry, and let's print it with some beautiful text. DC entry accuracy and the accuracy DC entry. Yeah, you can say DC entry accuracy without bagging. Okay, now let's run it. Oh, 91%. It's a great accuracy that DC entry will give me on the dataset of the breast cancer. Now, sometimes the base model will perform better than the bagging, but but in most cases bagging is a very uh, accurate. Okay. Okay. Now let's say we have to use the bagging classifier now. Bagging classifier. Now let's say we have a variable of bagging classifier, and in which I use my bagging classifier, and now you have to use a few important hyperparameters. The first one is the n estimator. Okay, it means how many DC entry you want to use. Okay, this is a very important. Okay, before this you have to set the your base model. Okay, your base estimator, basically base estimator is equal to the DC entry classifier. Okay, the random state will be a 42. Now you are using the DC entry. Okay, the random state is not compulsory here, you can remove it. Now you use the 50 DC entry. Okay, after this how many samples you want to use. Okay, max samples, basically how many rows you want to use. Okay, I want to use the 80% of rows. Now the bootstrap, it's mean the with replacement or without replacement. if if bootstrap is true, then it's mean you go with replacement, and vice versa. Now the random state equal to 42, and n job equal to -1. This will give me the data, the whole detailed answer. Okay, now let's fit the data into it. Let's say we have the bagging classifier dot fit, and your x train and the y train, and we have a bagging classifier dot predict, and in which I want to use the x test. Okay, my 30% of data. Now in which you have to store this into a specific variable. Let's say y predict bagging. Okay, now for accuracy you use the simple method, same method. You just simply copy it and paste it here, and accuracy bagging, and now okay, sorry, uh, bagging and with bagging, and now the y test and y predict bagging. Yeah, I think it's will okay. Error, what's the problem? I think you have to use only estimator here. Yeah, I think that's a problem. Okay, it's working. Okay, you can see the difference between the accuracy. Without bagging we get the accuracy of 91%, and after bagging we get the accuracy of 95% with some tuning. So that's great. In this case we get a better accuracy with bagging. Okay, now I hope you will get it. After this I want to show you, okay, I want to show you the some more things about bagging. Let's say I want to show you bagging with OOB score. Let's make a variable of bagging classifier OB, and I want to use the bagging classifier. Sorry, bagging classifier. Again, I want to use a few more things here. Let's say we have. I just copy it. Now estimator is equal to DC entry, and an estimator, let's say 100, and max sample 0.8. This one is true, and I want to add one more thing here, that is OB score is equal to true. Okay, now random state 42 and -1. Okay, yeah, that's it. Now I want to check the accuracy score again. Sorry, OOB score. Let's simply copy it. Sorry, okay, I want to just type it. Bagging classifier OOB, and then dot fit, and the xtrain, sorry, xtrain, the ytrain, and let's print it with a beautiful message: bagging with OB score, and the bagging classifier OB dot OB score, this one. Let's print it. Okay, 96%. We will get a better and better result. 91% to 95, and 95 to 96. Oh, this is how you can improve your accuracy. There are a few more methods like GridSearchCV. You simply use it and you can get a better accuracy, basically a better value of your hyperparameters. Then you can simply set the value according to the GridSearchCV and you will get a better accuracy. Okay, I'm writing the code of GridSearchCV. You can simply copy it and run it. Okay, this is the code, you can see it. Now you can simply run this code. Basically this will take a lot of time, that's why I'm not running this. Okay, what's the problem? Only estimator, now it will working. uh, Base estimator, hmm, grid search CV, estimator. Okay, yeah, now it will working, but it will take a lot of time. Okay, so that's why I'm not running it here. Okay, I want to continue. Now after this, you can use the few matrices. Okay, it will working. Back CV result, you can see we get 97% of accuracy. Okay, after cross validation. So, and he will it will give me the few best advice, you can say. You can set the bootstrap equal to true, the estimated max depth none, max sample is 0.8, and n estimator is 100. So as we seen, I'm using the 50, so it suggests me to use 100 then I use 100, accuracy will increase from 95 to 96. Okay, this is how you can use the bagging classifier. Now the confusion matrix and classification report and few more metrics you can use. I just write the code, then you can see. Okay, this is a visualization code. You can simply copy it and then use for the visualization, and you can see it. The decision tree is performing better, 91%, than the best bagging. The after the GridSearchCV, it will give me the 94%, and the simple bagging technique, it will give me the 95%. So in this case, our simple bagging technique is working better. Okay, this is how you can use your bagging technique. Now I uh, want to ask about some types of bagging, then we will end the video. So basically in bagging we have mainly few types. The first one is pasting. Okay, the pasting is all about the row sampling without replacement. Okay, so basically this is the just a minute, this is the simple bagging. Okay, and this is doing a row sampling because you change the max samples. Max samples means the row. Okay, and you set bootstrap equal to true, it's mean with replacement. Okay, but if you copy this code again and just a minute, you paste it here, then if you set the bootstrap equal to false without replacement, now it become a pasting. Okay, it become a pasting. This is called a pasting, and you can see this give me the result of 94%. So more times bagging perform better, but sometimes, okay, you can see the bagging is performing better than pasting. So pasting is a type of bagging. Sometimes pasting will perform better, but most of the time bagging will perform a far better than pasting. Now we will discuss another type, that is random subspaces, in which no row sampling, you simply do a column sampling with replacement and without replacement. Okay, so basically just a minute, we have a code. You can see okay, this is, no, there's no code of sampling. Okay, you simply want to simply add one more feature here, that is max feature. Okay, now let's say I want to use we have a how many features, just a minute, data dot info. Okay, it's not working because data is not defined. Just a minute, I just check. Okay, we have 30 features. Okay, I want to use, let's say, the 20% of that 30 features. Just a minute, where's, okay, let's say 0.2. Okay, now it become, just a minute, I just set it comma and column. Now it become the random subspaces. Okay, accuracy is better than the pasting. Now if you set the random the bootstrap equal to true, and then it will drop. This is how you can set it. If you use the more columns like 0.8%, then no difference. So this is called random subspaces. Now if you talk about the random patches is all about the row sampling plus column sampling. So you have to change, you have to some changes, make some changes in row sampling, in rows and columns. So then it becomes the random patches. This is all about the random this is all about the banking classifier. You can simply use this classifier, this technique, this ensemble learning technique using this code, and so that's it. Hope you will get it. Thanks for watching.